Hi there and welcome to this video on setting up a RAG demo on NVIDIA AI Workbench. This video is aimed at those who want to experiment with large language models and RAG but don't necessarily have the skills all the time to stand up a complete GPU accelerated container environment. So what is NVIDIA AI Workbench? Well, it's a really easy tool that allows you to spin up a whole AI project in a virtualized Linux container environment on your laptop without having to resort to typing hundreds of long and complex commands, install software, and reading through lots of how-to guides on the web. It's really easy for beginners to get a leg up into the world of AI, and also for experienced data scientists, it's a really convenient way to quickly build and share a working environment. So, what do you need to get this LLM and RAG demo running? Well, the system requirements are fairly low, 16 gigabytes of RAM on your PC, Windows 10 or Windows 11, in fact it runs on Linux and Mac too, and about 40 gigabytes of disk space. Now, to be honest, I question this last one. I checked my disk space before and after installing Workbench and the RAG demo. It was 160 gigabytes free beforehand and 80 gigabytes free afterwards. So I probably recommend having around 80 gig at least of free disk space before you start. Now, one of the great things about AI Workbench is that you can run the GPU accelerated part of the workflow anywhere you have your GPU resources. You can run the LLM project locally on your workstation if you have a good GPU. You can launch it on a GPU accelerated server in your network, or you can use a cloud-based API endpoint like NGC or NVIDIA GPU Cloud. We're going to be using NGC in our demo, so you don't even need a GPU in your laptops to get this demo running. Okay, so let's get started. Before we go into Workbench, we just need to go to github.com and create ourselves an account on here. Very simple process to do. Just enter in a user ID and password to here. Create yourself a username on the GitHub system. This is so that we can store and retrieve projects from GitHub during the process of this demonstration. We just need to go through some of these mind-numbing verification tests before we start this, but very shortly, once this is done, we'll be into the portal. Now, it's going to send you an email as well with an authentication code. We just need to enter that in just so that it knows we're for real. And the first few screens that we're going to come across here are just a few welcome screens to GitHub. But apart from that, we're pretty much good to go. Now, next thing we need to do is go to ngc.com or ngc.nvidia.com and sign up for an account here. So you can enter a personal email address, a business email address as well in here. In the same way, create a password and verify that you're human. Another few tests to verify that you're human. This must be getting harder with AI these days to actually verify that people are humans. Of course, you've got an email address to verify. Once that's done, we've just got a few screens to complete here. You need to set up a profile within here, give it some details about yourself. But in a few seconds, you'll be in as NGC. Okay, so now what we're going to do is we're going to set up a personal key so that we can access NGC from our Workbench. Now, this is basically just as an alternative to a user ID and password. To do this, we just set up a key name, Workbench, expiry 12 months in this case, and we're going to choose all of the services within NGC so that we can get access to everything with this key. Now, once we've done this, it's going to give us the ability to copy this. Make sure that you copy this key straight away. You won't have access to it any other time. So go in here, put it into somewhere safe, a Word document or your email or something like that, just so that we can retrieve it later on when we need it. Now, as we're going to be using NGC, how many credits do we have on NGC to allow us to do these inferencing? Well, you can't actually see any of the credits from within here on NGC, but if we go to build.nvidia.com, which is another website which is gradually taking over from NGC for hosting AI models, what we can do is if we go to the profile section within here, we'll actually see it lists the number of credits. And every time we send an inferencing request or ask the LLM a question in this demo, it's going to debit those credits by 1. Okay, so every inferencing request is 1 credit. Now, how many do you get when you join up? Well, as you can see here, if you use a corporate email address, you get 5,000 credits to actually play around with the models on NGC and on build.nvidia.com. If you use a personal email address, you only get 1,000 credits. You can actually ask for more if you want to. That's absolutely no problem at all. Okay, so let's install AI Workbench. So go to the URL that is on the screen at the bottom now and click the download button. Next thing it's going to do is download this code, the installer at least, to your workstation. Then go to the directory that it downloaded that to and double click on the file. Now it's going to need admin rights, so it's just going to ask you a few times during this install for admin equivalents to install this on your workstation. Come in here, hit the begin install icon, and it's going to tell you about Windows Subsystem for Linux now. Now this is a virtual Linux environment that allows you to run your containers and applications within this virtual Linux environment on a Windows workstation. So it's just going to have to install this for you. It's going to ask you a few times again to get access to the base operating system. This shouldn't be a problem, hopefully, on your workstation. It's going to actually need a reboot as well. So after a few seconds of doing this, it's going to reboot your workstation. And once it's done, it's going to come back and restart again. So let's just restart our workstation. So automatically, when your workstation's back, you'll see it carries on downloading the Linux distribution that it needs to install with Workbench. If that doesn't work, you can type WSL --install at the command line if you run into a problem and just relaunch the Workbench install after you've done that. Another thing, if you get something like this, application error, it's probably something to do with the virtualization support. So go to the BIOS of your workstation and make sure virtualization is installed on there and enabled. Now this is going to take a little while to do, maybe 5 or 10 minutes, but once that's finished, you're going to be entered another question now. And we're going to select which container runtime environment we're going to use. We can use Docker, which we're going to have to install ourselves. What I'd recommend for this demo is to use the light version of Docker, which is called Podman. Now, before we continue, let's just go to that GitHub account that we created earlier on and just log into GitHub so it's there ready for this installation, because in a minute, we're going to need to install a code, or we're going to need to type in a code to enable the handshaking and logging in between the Workbench environment and GitHub. So now that's done, let's choose Podman. Once we've done that, click the next button. Again, admin privileges are just needed for this, and we're just going to go ahead and do this. Again, this is going to take us a few minutes. I'm going to fast forward through this process. You don't want to see paint drying, I'm sure. Okay, so as I said, we need to log into GitHub now and create a connection between GitHub so we can store projects, retrieve them, that kind of thing from the Workbench. It's going to give us an authentication code, which we're going to have to enter into GitHub. So let's just put this page to the side here and actually type in that authentication code. What I recommend is you do this in fairly short order, fairly quickly, because otherwise it'll time out and you're going to have to go in here and do that again. Just authorize NVIDIA to access the GitHub pages. Again, just verify our password there, and we're actually going to be good to go here. It'll come back to us automatically. Okay, so let's get started with our Workbench project, shall we? Go in here. The first thing it's going to do is it's going to say welcome to Workbench, and it's going to set up a default location for you within here. Now the default location in this particular case is your local workstation. You can have a remote workstation, you can have a remote server, or you can have a cloud endpoint, whatever you want. But in this particular case, we're just going to connect to the local workstation here and start off some projects. Now we could start a project here. What we're going to do in this case though is we're going to clone one from GitHub already. Okay. So what we need to do now is go into GitHub. We're already logged in there, no problem. and we're going to clone the project from there. So here's the URL it's expecting, the github.com/user/project. If you go to the page that I've highlighted down the bottom now, you'll see this is our RAG, our hybrid RAG project. And if you scroll down here, you'll see lots of details about what this includes, how to run it, all that sort of thing. Now, the first thing we need to do is we need to fork this project. So we need to clone this off to our own repository so that we can work on it, share it, sync it with other people without affecting the original project itself. Okay, so I'm going to create a fork for this project. In a few seconds time, I'm going to have a custom URL that I can use for Workbench to actually clone this project down to my local PC. So let's just hit copy on that. Now what I can do is go back into Workbench and paste that with Control V into here and hit clone. At this stage, what it's going to do is it's going to suck all of the subdirectory structure and all of the information down from that GitHub page onto my local workstation. Now you can see down the bottom here within Workbench that we have a section called building, and it's currently at number 1 of 34. So this is going to take about half an hour to fully build this project. So this is the great thing about Workbench, right? It actually installs all the prerequisites, all the requirements, all of the dependencies for you, all based on a scripted process. So it's very easy to repeat and replicate over and over again. Now this is going to take a little while. While this is happening for the next 30 minutes or so, we're going to fast forward most of it. But let me just show you a little bit about Windows Subsystem for Linux while we're waiting. Okay, so if you go to the Start menu within Windows and just type WSL, you'll actually see here you can click on a link here. And when you do, it actually shows you this little Linux environment that is created on your Windows workstation. And you can just do standard stuff on here as you would do in Linux, like you can type the cd command, for instance, the change directory command. In this case, if we do cd/home/workbench, it's actually going to go in here and show you the contents of the subdirectory structure that Workbench created within here. If we go even further into this subdirectory structure, we'll actually see the project as it's being cloned in for us. So you can see in this particular directory on Linux, we'll actually see here's the project. So you can see here code, data, some of the commands in there. If you compare that to what's on GitHub, you'll see codes, data, etc. within here as well. Okay, so it's just access to that Linux VM. What we can also do while we're in here is we can see what containers are running. For instance, there's a great command called podman ps. If you type that, it'll actually tell you what containers are running. As you can see, it's already spun up a container for us within this environment, the Workbench proxy container. Now, we can also get access to this file system directly from Windows Explorer if we want to as well. So we can go in here, right down at the bottom here, you'll see we've got a Linux icon. Click on there, you'll actually get access to that file system. So Workbench, go in here again. If we go to home, Workbench, and the same directory as we did at the command line, we'll actually see all of the same files within here as well. So let's just fast forward past this whole section. As I say, go and grab a coffee. This is going to take about half an hour to build. And when this is finished, you'll know it's finished because you'll have the build process. If you run into problems during the build process, you literally just go in and restart the build process. It's as simple as that. You can actually go in and restart, and it'll start off where it left off. You can stop the build here if you want to, but obviously in this particular case, let's just leave it running, leave it to install all of the stuff that you need. Okay, so as you can see now, it's actually finished the process of building, and all we need to do now is hit the open chat icon, which is now come out as green at the top. Once we do that, now we're getting to the stage where we need to connect our Workbench environment into NGC. Now, if you remember just now, we created an API key, a secret key for ourselves to get in. So let's just cut and paste that into the box here. Go to the values, hit Control V. Just make sure that you don't have any training spaces or spaces at the start or anything like that, because it could actually cause us problems later on. We're just going to check on that. That looks absolutely fine. Hit the continue button, And now, as I said earlier on, the great thing about this demo is it doesn't actually need a GPU. You can go to a cloud endpoint, a local endpoint with GPU power, or you can just use the workstation you're on. I'm going to hit continue without GPUs in this case, because all of our inferencing is going to be done on NGC. Now, after a few seconds, what will happen is another container is going to spin up, and we're going to have access to a local web UI running locally on our Linux environment for RAG. If we go back to our Linux environment, as I said earlier on, if we type podman ps, you'll actually see the project has actually spun up a whole new container here to give us this service. It's also spinning up other things as well, like our vector database, for instance. So now at this point, we've just got to hit the setup RAG backend. Again, this is going to go through some nice trickery and scripting in the background to actually set up our retrieval-augmented generation backend for us. And in a few seconds' time, we can then select which model it is that we want to use. Okay, so we've already chosen Cloud Endpoint. You can see here it's just saying inferencing is ready, but our vector database may still be spinning up. Well, we're not going to use it for our first question, so let's just let that spin up in the background. Now we can select whatever large language model we like. In this case, I'm going to choose the Mixtral 8 by 22 billion parameter one, and let's just go ahead and just see if this guy works. Let's just type hello NVIDIA and see what it comes back with. Okay, so as you can see in this case, it's come back and it's talked to us. You know, it's actually saying, hello, I'm not affiliated with NVIDIA. So we know this is actually working correctly. So that is great. So what if you type in something within this command line here, hit submit, and you get an error? Well, 9 times out of 10, this is going to be because the API key that you put in there is actually set up wrong. So all we need to do to verify and rectify that is go back into our workbench, click on the environment section within here, scroll down to where it says secrets. You can see there's our API key in there. Just go ahead, edit that. It might be completely wrong, so let's just edit this secret and actually paste back that value that we copied from NGC earlier on. Again, double check to make sure we've got it right. Hit the save button, and hopefully in a few seconds time we'll be able to go back in. We just need to restart the environment. Okay, this is going to restart all of the services in the background, and authenticate with NGC to make sure that we've got a valid authorized connection within there to do our inferencing in the cloud. Okay, once again, continue without GPUs. We're not using GPUs in our workstation for this demonstration. And within a few seconds' time, we'll be able to talk to the large language model. Let's try it again. Oh, sorry, we just need to set our RAG backend up. You'll notice that you'll need to do this every time you turn your laptop off and back on again. Just need to do this final process of setting the RAG backend up. It only takes a few seconds just to spin up some containers and databases, that sort of thing. Choose Mistral AI again, type hello, hit submit, and as you can see there, it's working. We're talking to our API in the cloud. Now, let's try and ask the large language model something a little bit more complex. So what is an H100? So don't forget, at the moment, we're just talking to the Mistral AI large language model directly. Okay. So it says in this case, sorry for any confusion, but H100 could mean literally anything. So I'm not going to give you a great answer to this. Okay. So this is typically what happens. This is probably the best that happens in large language models. So in a lot of cases, it'll actually hallucinate and give you a completely wrong answer. So here's some data that I've prepared earlier. So I've just got an NVIDIA AI Enterprise white paper. I've got the H100 data sheet, and I've got some information about my hometown, which I'll show you in a minute. Now, in order to ingest this into our vector database, what we're going to need to do is copy it in here. Now, I've noticed that the drag and drop doesn't really work in here. So the best thing to do is just click on the icon here, go to the files within your file system and just hit open. Now, I've noticed that the files that you create in here, try to make sure they're quite small PDFs, because this particular application, this particular demonstration actually can time out if the documents are too big. So I'd say under 1 megabyte in size, try to choose PDFs in that kind of range. These 3 PDFs are all under a megabyte in size, as you'll see in a second, and they import really nicely into here. So within a few seconds time, we'll actually have the ability to query these and use these with our RAG model. As you can see, it actually shows us the size there of those 3 files. So let's just do exactly the same thing again. We've given it information about an H100, so hopefully this time it comes back with something a bit more meaningful. And as you can see, in this particular case, H100 is a Tensor Core GPU designed for exceptional performance, all of that stuff, which is taken directly from that PDF. So what just happened? So we processed our PDFs locally and stored the information as embeddings in our vector database. When we asked the question about H100, we retrieved the relevant answers from the database and sent it to the LLM in the cloud to allow it to answer the questions correctly and more accurately. So let's try something else. So we've downloaded the NVIDIA AI Enterprise Solutions overview. So let's go and ask it a question about NVIDIA AI Enterprise. Does NVIDIA AI Enterprise support Tanzu, for instance? Hit submit. And what it's coming up with again is I'm a little confused. It doesn't explicitly say so, but NVIDIA has a partnership with with VMware, so it's kind of trying to make something up that sounds meaningful. Let's do it this time with the toggle for the vector database, which does have this information actually included within it. And as you can see at this stage, it comes back, yes, it does in fact support VMware Tanzu. Now, you can use whatever document you want in here and you can choose the best based on your own information. As you can see, I've imported a document here on my hometown, Perford, which actually has an interesting link to Ada Lovelace, the the architecture from NVIDIA. So if I hit submit and go in here and ask it a little bit about Ada Lovelace, so this is the base large language model, you can see here it gives us some generic information about her, Charles Babbage, Lord Byron, all that sort of stuff. Okay, but no links to Perford, not surprisingly. Now, if I toggle on that vector database and actually ask it the same question again, what you'll see this time is that it gives you a slightly different answer. So it tells you a lot of the information that we had before, but you'll notice down the bottom there, it says the Lovelace Drive in the area was named after her. Now, this is in fact correct. So Ada Lovelace was a resident of Perford, and Lovelace Drive in Perford is actually named after her. So it's picked out that information straight out of that document. So what we can do is we can actually choose another large language model, whatever we want in here, and really the key here is to actually play around with it a little bit and, figure out what's best for you, what demos are best for you. Try to use information that's relevant to your customer, maybe pull down some PDFs of their website if you're doing a demonstration. The choice is yours really, and playing is key. Now, if you want to close this environment down, all you need to do is go back into Workbench, stop the project and close. This is actually going to close down all of the containers and environments and runtimes that we're actually running in here. So it's probably good practice to do this before you shut your workstation down. Okay. After you've turned your workstation off, say that you're at the next customer or doing your next demonstration, all you do is click on the AI Workbench option within here, click on your local endpoint. As you know, we're running all of this stuff locally, apart from the inference, which is being done in the cloud. Open this project up and hit Open Chat. Once again, we're going to use no GPUs for this. This doesn't need a GPU. We're doing all of our inferencing in our NGC cloud. In a few seconds time, you've just got to go in here and enable this and start this up. Let's choose another model in this case. Let's go to our Llama 370B model and actually choose this, say hello to that and see what it says. Okay, so we've got the option in here to do various things. Hello, it's nice to meet you, etc. Okay, so all of the demos within here are really up to you what you do. Okay, so I hope this video gave you what you needed to set up a complete working RAG environment and also gave you some useful experience with NVIDIA AI Workbench too. Thanks for watching.